Okay, in this example, in this video actually, we're going to go and show another example of solving a polynomial inequality using a sign analysis. And a sign analysis is a very powerful tool, as we've stated before. In order for us to perform this sign analysis, we have to identify our critical points, and those four polynomials are the zeros or the x-intercepts of the function, of the polynomial. So they are the zeros of the polynomial. So let's go ahead and look at an example. Let us say, where is x minus 3 squared times x plus 1 cubed times x plus 5 greater than or equal to 0. So let's go ahead and ask this question. We say, wow, that's a doozy of a question. And I would agree, it's definitely a doozy of a question. However, if we perform a sign analysis, it's really not that bad. Our first step will be to identify our critical points. And I abbreviate critical points with CP. So every time we see CP, that stands for critical point. So the first thing, if we want to identify the critical point, that's going to be the zeros of our polynomial. We're going to have to set this polynomial equal to 0. So we can split this up and set x minus 3 squared equal to 0. We can set x plus 1 cubed equal to 0. And we can set x plus 5 equal to 0. And we spent a lot of time graphing polynomials, so solving for these zeros should be relatively easy. We would take the square root of both sides. Solving this portion, we would get x equals to 3. And I remember that the factor corresponding to x equals to 3 is x minus 3 squared. Solving this guy, we're going to get x equals to negative 1. And I remember that the factor corresponding to this 0 is in fact x plus 3 cubed. X plus 1 cubed. And then last over here, the 0 corresponding to this factor will be x equals to negative 5. And plugging that in, we know that this will be the factor, not plugging this in, we know the factor x plus 5 corresponds to the 0, negative 5. Now we're going to go ahead and perform our sign analysis since we know our critical points. I'm going to write a number line over here, and I'm going to arrange my critical points, also known as my zeros, in ascending order. Starting with negative 5, because negative 5 is the smallest value, negative 1, and then positive 3. And I don't have to draw it to scale. I only need to write it out so I can clearly see definitive intervals. So now I recognize that I could be changing signs in 1, 2, 3, 4 different intervals. I could change signs in this interval, the third interval, or the fourth interval. I could be changing signs here. Now we're going to arrange our factors. And my factors, it does not matter which order we place our factors. It makes no difference at all. So I'm going to have my first one, x minus 3 squared. My next one, x plus 1 cubed, and that's a plus 1 cubed. And my last factor, x plus 5. So now I'm going to work them through step by step. I'm going to analyze this first one, x minus 3. Let me make sure I wrote that correctly, and we can see it. So this is x minus 3 squared. I like working with this one because x minus 3 squared corresponds to the critical point of positive 3. But no matter where I am on my number line, if I square any value, we know it's always going to be positive. So that is very nice. I enjoy working with terms that are squared or raised to the fourth power, any even power, because they are very nice to work with on a consistent basis. But that doesn't mean we can't work with the other ones. So x plus 1 cubed. X plus 1 cubed corresponds to the critical point of negative 1. Pick any value to the right of negative 1. If I pick any value to the right of negative 1, for example 0, and I plug it in, 0 plus 1 gives you a positive value of 1. Cubed, I'm always going to have a positive to the right of negative 1. Picking a value, I'm going to pick a value to the left of negative 1. I pick negative 2. Negative 2 plus 1 is negative 1, and I cube that. That's going to give me a negative. So anywhere to the left of negative 1, x plus 1 cubed will be negative. And last, x plus 5 corresponds to my critical point of negative 5. Picking any value to the right, I'm going to pick, let's pick 0. I like 0, it's over here, but it doesn't matter, it just has to be to the right. 0 plus 5 will give me a positive 5, so everywhere to the right of negative 5, x plus 5 will be positive. Everywhere to the left, it will be negative, plugging in like negative 6, negative 6. Negative 6 plus 5 gives you a negative 1, so you can plug them all in independently, or you can just be familiar with the trend. So remember here, I am multiplying each one of these terms together. So what should I do with each one of my solutions, or each one of my signs? I should multiply the positive times the negative times the negative. So I know my function f of x, positive times a negative gives me a positive. Positive and a negative and a positive gives you a negative. Positive times a positive gives me a positive, and a positive and a positive and another positive gives me another positive. So my question here wanted to know, where is this function greater than or equal to 0? So it's greater than or equal to 0 over to the left of -5. So I would write that as negative infinity until -5. I never include negative infinity, and I'm going to include -5 because we have a greater than or equal to symbol. We're going to join this, and we join this again over here at positive, where it's positive again, and it starts becoming positive at -1. And notice we have a little break at 3, but at 3 the function is equal to 0, and 0 is included here, so we're not going to stop at 3. We're going to continue on until positive infinity, and we're going to include -1, and we're going to not include negative infinity. So now, let's say I asked, let's change up this question ever so slightly. Let's say I asked you, where is this function greater than 0? So I want to know where x minus 3 squared times x plus 1 cubed times x plus 5, where is this greater than 0? Let's see how that changes. So he's going to be greater than 0, again positive. He's going to be positive here from negative infinity until -5. We are not going to include negative infinity, and this time we're not going to include -5. He's positive again over here in that third interval, starting at -1. But notice, we don't want to include 0 because this is just greater than 0. So we are going to stop at 3. We're going to stop at 3. We're not going to include -1, and we're not going to include 3. And then we start again at 3 because he's positive again, and then he goes on out to infinity. So be very careful here because this can distinctly change depending on whether or not you have a greater than or equal to, or a greater than sign, or a less than or equal to sign. So let's go ahead just for practice. Let us determine where this guy is less than 0. Less than 0 being negative, and he's only negative between -5 and -1, and this would not be inclusive. And let's say I asked you, where is this guy just less than or equal to 0? He's less than or equal to 0 along that same interval, but now we're going to include them using a set of brackets.